On some of these notes. I'm not going to go through the radian circle in this section and the special right triangles, but we are giving you a reminder here of the triangle triples. These are great when you recognize them. We'll show you in these notes how we can put those into play a little bit as well. So that's just kind of a review from the other day. This as well, knowing that if XY was in the first quadrant here, and it looked just like this, yeah, we come up with all of these ratios, and guess what? Everything would be positive. You know, you have a positive X, you have a positive Y, and R is always positive. So any of these ratios you come up with will be positive. Well, it's going to change when we go to a different quadrant. So over here, the A, if you've seen this, you know, all students take calculus kind of memorization before, this device is just to tell you that everything will be positive when you draw a triangle over here. Well, when we draw a triangle over here, that's not the case, because what happens now is that, oh, we're going left. So like it's like the opposite of X over here now. So we're still going up, but think about X as being negative now. Well, what this device tells you is that since sine does not deal with, you know, X at all, it's still going to be positive. You know, opposite over hypotenuse is still going to be positive. So just what this means here, whenever you see this, is that sine of theta is also going to be positive there. Likewise, cosine. If we go to the fourth quadrant here, these aren't great triangles, sorry, but we have a positive X, but now we have a negative Y value. So cosine will be positive over here, but obviously the sine will be negative. Now, if one of cosine or sine, one of the dimensions is negative, then obviously the tangent's going to be negative, because opposite over adjacent would be negative, but not in this quadrant. Tangent is positive in this quadrant because if we were to draw a right triangle here, we have the opposite of y, so a negative over a negative is going to create a positive. So everything is positive here, all of them, sine here, cosine here, tangent here. That's what this thing is doing. It's telling you where it's positive. Now, obviously, if sine, let's just say, was 1 over 3. Let's just make up a value. If it was 1 over 3. Well, obviously, this one would then be 3 over 1 because they're reciprocals of each other. So since sine is positive, obviously cosecant is also going to be positive because they're just reciprocals of each other. And likewise, cotangent will be positive here, and then secant will be positive there. So that's what that's basically having you go through. Okay, so to put this into application, plot the point which lies on the terminal side of an angle, theta. It's given, and find the exact value of the requested trig function, no calc. So basically, I know I'm in the third quadrant here. How do I know that? Well, once again, the negative values. So I'm going to go left 1.2, I'm going to go down 0.5. So I'm here. I can draw a reference triangle, here, and know what's going on. Well, I went left 1.2, I went down 0.5. What's my radius going to be? Well, once again, no calculator. How could we possibly do this? Because we know the ratio of the 5, 12, 13 family. So basically, the 5, 12, 13 family is 0.5, 1.2, and then a positive 1.3. Again, ours is always positive. So now I'd be able to answer those questions from that. Well, remember, it's a ratio. If I take 0.5 to 1.3, I can move the decimal over and take 5 to 13. So really, you don't even have to think about the decimals. Just think of the 5, 12, 13 family. So sine of theta, which is, you know, reference angle right here, would be opposite over hypotenuse. So make sure we get negative 5 over 13. And that would be my exact value simplified. And then secant theta would be not adjacent over hypotenuse, but hypotenuse over adjacent. So that's where we would get the 13 over 12. All right, 3, negative 3. Well, now I know I'm going right and I'm going down. So once again, oh, and by the way, I should have connected here. See how sine is negative? Well, we knew it would be negative here. And see how secant is positive right here? We knew it would be positive. Oh, I'm sorry. Did I mess that up right there? I did mess that up. Well, see, there you go. I just found it, and I'm not going to start the video over because this is good. Secant should have been a negative over a positive. Actually, a positive over a negative, but we should have had a negative there. So connecting that back helped me find my mistake that I went too quickly on there. Awesome. Okay, so 3, -3. So right 3, down 3. Okay, so right 3, down 3. There's actually an ordered pair here, and if I connect that ordered pair back to the origin and then drop to the positive x-axis, I'm going to have right 3 and down 3. All right, well, I'm hoping that you understand that this is a, what type of triangle? 45, 45, 90. So this would be 3√2. So it's a 45, 45, 90. So tangent is going to be opposite over adjacent, -1. And then cosecant is the reciprocal of sine. So 3 over 3√2 becomes 3√2 over -3, which equals the opposite of √2. Again, cosecant down here should be negative. The only ones that are positive are going to be cosine and secant there. But everything's positive up there. Okay, so I think, no, let's do a couple more problems before I go to the next video. I don't want to make these videos too long in case it doesn't record. So here, basically, it's just giving you some information. Find tangent if sine is positive. That's what I want you to think about. Sine is positive. We can't be here, we can't be here. The sine is positive. Oh, by the way, cosine is negative. Okay, so where's cosine being? Well, if I go left, that's going to be negative up here, right? Cosine is negative here. Nothing's negative up there. So we know we're in that quadrant. So what do? Well, I think about being in that quadrant, and some problems are easier than others, but I think about sine. Well, that would be √2, 3, and then cosine is a -1 right there. So I should be able to find tangent of theta, which is right there. So opposite over adjacent, we're going to get a -√2. So we look at the information presented to us and we figure out which quadrant we're in. All right, so right here, just starting right here, thinking about that, cosine is negative. So we can't be here, we can't be here. Cosine is essentially positive in these two. So it's got to be one of these two. Oh, by the way, tangent is positive. If you remember, tangent is not positive up here. It's positive down here. So we know that we are in the third quadrant, okay? So I make my triangle and I set it up as tangent being opposite over adjacent, and you got it. Not a lot of thought process when you know your families, 5, 12, 13, okay? Only thing you gotta be careful of here is that this actually went left and this actually went down, but the ratio became a positive tangent. All right, so what are they asking for? They're specifically asking just for cosecant. So from this reference angle, that would be the reciprocal of sine. So it's gonna be 12 over 13, -12 over 13, and the reciprocal of that, so -13 over 12. All right, I'm going to cut off this video and start a new one for the rest of this sheet. Maybe.